Assalamualaikum and good morning to all of you guys. How are you guys today? Good? Alhamdulillah. Okay, for our class today, Miss want to teach our new subtopic, which is binomial distribution. But before that, let me explain to all of you guys what does it mean by binomial distribution. It is the probability of discrete random variable. Next, before you perform the binomial distribution, there's 4 conditions you need to satisfy. If one of these conditions not satisfied, then you cannot proceed to the binomial experiment. The first condition is the number of trials, or we denoted it as n, are identical, which means the experiments will be repeated n times under same condition. Next, each trial will have 2 possible outcomes, which is success and failure. The third condition related to the second condition, which is the probabilities of the 2 possible outcomes will be constant. You need to take note that the probability of success will be denoted as P. Meanwhile, the probability of failure will be denoted as Q. To find Q, you just calculate 1 minus P, since it is P plus Q is equal to 1. The last condition is the trials are independent, which means each trial's outcomes will not affect the another trial's outcome. Next, let random variable S will be the total number of success in the n trials and read it as X is binomial distribution with parameter n and p, where n is the number of trial and p is the probability of success. To find a binomial distribution, you need to memorize the formula, and this is the formula. There's 2 ways to find the probability. The first way is you can calculate it manually by using the formula I mentioned earlier, and the second way is you can use statistical table, but make sure that you look at the statistical table carefully. Lastly, you need to know and remember the formula for mean and variance of the binomial distributions. The formula for mean is n times p, meanwhile for the variance is n times p times q. There's 2 examples of question that you can use binomial distribution to calculate it. The first one is tossing a coin and the second one is rolling a die. That's all for the introduction. Thank you.
My name is Teacher ATHIFA RUFAIDA and I will be explain about Poisson distribution. Okay, what is Poisson distribution? Poisson distribution is the discrete probability distribution that useful when n is large and p is small. Okay, when the independent variable occur over a period of time, that is called Poisson distribution. Okay, Poisson distribution can be used when a density of item is distributed over a specific region like unit of time, volume, area, and or distance. Okay, for example that I can give, we might be counting out the number of car accident in a day. Okay, in Poisson distribution, we use lambda as the probability of occurrence for a variable, where lambda is the mean number of occurrence in a given time interval. So here are the probability function of the form for Poisson distribution that we will use to calculate probabilities. Okay, the mean of the Poisson distribution is lambda. So mu is the mean of the random variable x, also equal to lambda. Then we could use mu as our parameter, but in Poisson distribution we often use lambda. Okay, moving on to the variance, which is we will label as sigma square, that is also equal to lambda. So we can conclude for Poisson distribution, the mean and variance are equal. Okay, next let's move on that I will be explain about Poisson distribution as an approximate to the binomial distribution. Okay, for a random variable with parameter n and p, when the number of trial n is large and the success probability p is very small, which is near to 0. Okay, the binomial distribution approach the Poisson distribution with the parameter given by lambda is equal to np. Normally, we change the binomial distribution to Poisson distribution when np is less than to 5. Okay, so the mean for this Poisson approximation distribution will be lambda equal to np. So, this is the mathematical expression for Poisson model is used to approximate the true binomial result. As I mentioned previously, the characteristic of Poisson distribution, mean and variance are each equal to lambda. So thus, when using Poisson distribution to approximate the binomial distribution, we use mean equal to np and the standard deviation is equal to square root of np. Okay, that's all for Poisson distribution and Poisson distribution as an approximate to the binomial distribution. Hope you can understand it well. Thank you.
Next, moving on to the Q&A section. As for today, teacher would like to explain about one question which is under the topic of binomial distribution. The question asks, if 20% of the bottles produced by a machine are defective, determine the probability that out of 4 bottles chosen at random, the first one is 1, second is 0, and third, at most 2 bottles would be defective. So, as for the solution, let X be the total number of defective bottles. X is a binomial distribution with parameter n and p. N is the total number of bottles, which is 4. P is the probability of success, which is 0.2. And Q is the probability of failure, which is 0.8. Denoted X, approximate B, 4 and 0.2. And all of the values given must be substituted, and the formula will be 4C2 times with 0.2 to the power of x times with 0.8 to the power of 4 minus x, where the value of x must be 0 until 4. For question A, the probability is 1. So, we need to substitute the value of 1 into the formula, and it will be 4C1 times with 0.2 to the power of 1 times with 0.8 to the power of 3, and the answer will be 0.4096. Second, for question B, the probability is 0. It will be same like this previous method, which is we need to substitute the value of 0 into the formula, and it will be 4C0 times with 0.2 to the power of 0 times with 0.8 to the power of 4, and the answer will be 0.4096. Third, for question C, the question asks to do at most 2 bottles will be defective. Firstly, we need to work on for the probability of 2. So, the value of 2 must be substituted into the formula, and it will be 4C2 times with 0.2 to the power of 2 times with 0.8 to the power of 2, and it will give the answer 0.1536. As for the question said at most 2 bottles, so the inequalities will be less than equal. Then we need to sum up all of the probabilities starting from 0 until 2. So 0.4096 plus 0.4096 plus 0.1536, and the final answer will be 0.9728.
Assalamualaikum and good morning everyone. My name is ISMAHADIRAH binti IRWAN and you can call me Miss Isma. So today I will give you an example of Poisson distribution. So let me go through the problem first. A statistician records the number of cars approach an intersection. He finds that an average of 1.6 cars approach the intersection every minute. Assuming the number of cars that approach this intersection follows a Poisson distribution, what is the probability that 3 or more cars will approach the intersection within a minute? So, can you imagine how to solve this problem? No? Okay, let's solve this problem together. From this problem, the lambda is 1.6. The goal of this problem is to find P as more and equal than 3, because the probability that there are 3 or more cars approaching the intersection within a minute. Since there is no upper limit on the value of K, which is 3, 4, 5, 6, 7, 8, and we don't know the nth value, this probability cannot be computed directly. However, we can find P more and equal than 3 using its complement, which is P less and equal than 2, to give P as more and equal than 3. So we can use the Poisson distribution formula, which is e power of negative lambda multiply with lambda power of s over x factorial. So first, we need to find the P as equal to 0 using the formula. So 1.6 power of 0 multiply with e power of negative 1.6 over 0 factorial, and we find it using the table distribution. Next, we find the P as equal to 1 and P as equal to 2. So to find P as less and equal than 2, we just add all the P as equal to 0, P as equal to 1 and P as equal to 2, and we get the value, which is 0.783. Next, to find P as more and equal than 3, we know that the number is continuous, which is 3, 4, 5, 6, 7, 8, and we don't know the nth value. So to find P as more and equal than 3, we can find it using 1 minus P as less and equal than 2. So just minus it, 1 minus 0.783, and we got the value. And that's all from me. Thank you.
Hi, greeting to all of my students. So now you're with me, Miss IFFAH, and now we will see an example situation of Poisson distribution approximation to binomial distribution. So let us read the question first and highlight on all of the information given. The probability of any one letter being delivered to the wrong house is 0.01. On a randomly selected day, Peter delivers 1,000 letters. Using a Poisson approximation, find the probability that Peter delivers at least 4 letters to the wrong house. Okay, now that we have highlighted all the main points, so let us find out what was the information given. So first, we have the probability 0.01. Probability is P, and for second one is Peter delivers 1,000 letters. 1,000 is a value of n. Using a Poisson approximation, find the probability that Peter delivers at least 4. At least 4 is x greater than equal to 4. Okay, so I'm sorry that we have to zoom in, zoom out. And the first step, let us write down all of the information given. Okay, our n value is 1000, p value is 0.01, and what are we searching for is the probability of x greater than equal to 4. Okay, so now from the information given, we can write down the binomial approximation, which is x approximate b. Our n value is 1000 and our p value is 0.01. Okay, but from the question, we need they want us to use Poisson approximation. So how are we going to convert the binomial approximation into Poisson approximation? So from the previous lesson, we know that from binomial distribution, we know that expected value is equal to NP, while expected value from Poisson distribution is equal to lambda. And then we can conclude that expected value equal to NP equal to lambda. So from this, we can convert the binomial approximation into Poisson approximation, which is x approximate p notes lambda, which is 1000 multiplied with 0.01, we got 10. Alright, so now that we have the Poisson approximation, we can search for probability x greater than equal to 4, which is equal to 1 minus probability x less than equal to 3. Why we need to minus? It is because we want to search for the value from x equal to 4, 5, 6, 7 and to the n value. But for this situation, they don't give us the n value. So we need to minus 1 minus with the value before 4. Right? So 1 minus p x equal to 0 plus p x equal to 1 plus p x equal to 2 plus p x equal to 3. Alright, now that we have the equation, then we can substitute the value into our formula, which is our formula is exponent negative np to the power of x over x factorial. So 1 minus exponent negative 10 to the power of 0 over 0 factorial plus exponent negative 10 to the power of 1 over 1 factorial plus exponent negative 10 to the power of 2 over 2 factorial plus exponent negative 10 to the power of 3 over 3 factorial. Okay, you guys can calculate using your calculator, sum up all of the value, and then we will get 1 minus 0.0103, and then you can total up all of this. We will get 0.9897. So I'm sorry that I have to zoom in, zoom out to make it clear. Okay, I hope you get what I was explaining. So that's all from us. I hope you guys understand what the lesson well. See you guys later. Bye.